my name is Nita and I'm going to be introducing you to function notation. First we're going to look at a cute little function I call q. Don't worry too much about the math in q because we're not going to worry about it yet. Q is just a first introduction. It's just our first function to look at. Q, as I said, is its name. I could have named it anything I wanted. I could have named it Esmeralda. It just would have taken more paper every time I wanted to introduce it. So since mathematicians are generally lazy, we go with little names like Q, or usually F or G or H. Those are the most common names for functions. Next to Q in parentheses here we see the letter X. X is usually the one we use as a placeholder, and we have a very good reason for that. The reason is that it's usually the one we use as a placeholder, and that's it. It's just that we're used to seeing it, and so you can get used to seeing it. And then the next time you see X in parentheses after a name like Q or F or G, you know that that's a placeholder, or at least you can make a pretty good educated guess. After that, on the other side of the equal sign, we have the instructions. The instructions just tell us what to do with X. So whatever X is, this placeholder, whatever I've put in a spot, is going to get squared, multiplied by 5, and have 7 subtracted from it. And that's anything I put there. 7, negative 18, a million, no matter what goes into this spot, I square it, I multiply it by 5, and I subtract 7. Doesn't really matter if it's math, even. If I put the letter A here, I get 5 times A squared minus 7. So let's ignore the math. It's just instructions. Let's look at a special function. I'd like to introduce you to f. F is a function that takes something and makes it a square. So whatever we put in here, say we put a blue triangle, I get the square version of that. So I'm going to get a blue square. If I put in, say, a yellow diamond, I get out a yellow square. Even if I put in a yellow square, I still get out a yellow square. There's no problem with that. The function doesn't have to change anything. It was already good enough. The function's just here to make sure things are square. It does the same thing to everything, makes it a square. We take a square, we make it a square, still a yellow square. And it is okay even if I put in different things, like I saw the diamond, the square, and the yellow triangle all give us a yellow square. It's fine if this function takes a bunch of things and all makes them the same at the end. That happens a lot, actually. It's okay if I put different things in and I get the same thing out, but what we do know, remember, about functions is that every time I put in a yellow triangle here, I have to get out a yellow square. I can't put in a yellow triangle and get a purple square. I have to get the same thing every time. So now let's go back to our first example. I had this function, I had its definition. Whatever I put in there, I said I was just going to square it, multiply by 5, and subtract 7. The only reason I'm squaring first is because of order operations. So let's say I put 2 in there. Now this is my placeholder. I just put 2 squared multiplied by 5 minus 7. So that's 4 times 5 is 20 minus 7. That gives us 13. And that's all there is to it. This has been really fun. I look forward to working with you next time.